Hello, welcome to today's class. And this class is going to be very exciting and fantastic. Hi, scientists. In our last class, we learned about sound and vibration. Today, we are going to be learning another interesting topic. Guess what? What's the topic? It's where does echoes come from? Sound travels in waves a lot, just like the way water travels in waves across the ocean. Yes, water travels too. What is echo? Echo is a repeated sound that is caused by the reflection of sound wave from a surface. The sound is heard more than once because of the time difference between the initial production of the sound waves and their return from the reflecting surface. This is echo. Have you heard echo before? Have you heard an echo before? Yes, I have. I don't know about you. As you can see in this picture, the dog is barking at a lady. The sound travels through a wave that we should call sound wave. As sound moves, they sometimes eat things. When a sound wave hits something such as wall, it will reflect or bounce back. As sound wave move, they sometimes eat things, just like in the picture. You see, the sender hits an object and the echo comes back. Now let's watch this video to learn more about echo. Yes, I want to watch. I'm waiting for the video.
Whenever I'm up at the mountains, I usually like to shout, Yo! And I hear myself over and over again. You may be familiar with this. It's called an echo. On the other hand, if you're inside a big empty room which doesn't have enough people in it, or hardly has any furniture or carpets or cushions, and you start speaking over there, then you sound something like this.
Testing 1, 2, 3. This is what it sounds like when you are speaking inside an empty room.
It's a little annoying because sometimes you can't understand what people are saying. This is called a reverberation. But what exactly is this reverberation? And why does it happen in empty rooms? And why do we hear these echoes at mountains? Well, that's exactly what we'll learn in this video. We'll see what these things are, why do they occur, and we will also learn how to reduce these effects to improve the sound quality. Alright, the main reason for echoes and reverberation is because sound can reflect. So for example, when you're at the mountains and you shout, Yo! The sound waves keep traveling forward until it meets an obstacle. In this example, another mountain. And just like how when light waves or water waves hit an obstacle, some of it bounces back, similarly over here, some of our sound waves will also bounce off that mountain, making its way back towards you, and finally, you will hear a second yo. And this process can keep continuing, giving us multiple echoes. But of course, you may know that as sound travels more distance, it becomes more and more feeble. And so the subsequent echoes that you hear will become more and more feeble, and after 3 or 4 reflections, you can no longer hear it. So let's look at this effect one more time. Yo! But why doesn't the same thing happen when we're inside an empty room? Why can't the walls of the room reflect sound and make us hear echoes? Well, they do reflect sound, but they are much closer to us compared to the mountains. And as a result, we hear the reflected sound much quicker. And so when the sound undergoes multiple reflections, the time gap between each subsequent reflection that we hear is very small. And as a result, our brains cannot tell when one sound ended and when the next reflected sound began. Now to understand this better, we can actually go ahead and do a demo. So in this editing software, I have copied the original yo sound and pasted it multiple times to simulate the echoes. Now when we play this, we'll first hear this sound, the original one, then the first reflection, then the second reflection, and the third and fourth. And the gap that I've kept now in this case between each sound is about 0.8 seconds. So let's play and see what we hear. Here goes. Yo, 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 yo. This was very similar to the mountain case. I'm pretty sure you could clearly distinguish between the different reflected sounds. So we'll call this as echoes. And so as we saw, 0.8 seconds is big enough for our brains to differentiate between the different reflected sounds. So let's reduce that gap and see what happens. Now I have made that gap 0.4 seconds. Let's see if we can hear the echoes. Here goes. Yo! Yo! Again, I'm pretty sure you could still hear the individual sounds, the individual reflected sounds. Let's play it one more time. Yo! Yo! So we will still call these as echoes. Even 0.4 seconds is big enough for our brains to differentiate the sounds. Now we will make the time gap very small. All right, now the time gap is about 0.07 seconds. So let's zoom in a little bit. This time gap now is 0.07 seconds. Let's see if we can hear the individual echoes. Here goes. Yo! Could you hear it? Let's play it one more time. Close your eyes and see if you can actually hear the individual echoes. Here goes. Yo! I don't know about you, but I couldn't tell the distinct echoes anymore. I couldn't tell when one sound ended and when the next one began. And it's for this reason we won't call these as echoes anymore. So let's hear it one more time. Yo! So these successive reflections are only prolonging that original sound in our head. And this prolongation of the sound or persistence of the sound in our ears due to these successive reflections is what we call reverberation. And in some specially constructed buildings like the Gokumbas of Bijapur or in some caves, the reflections can be very strong. And instead of hearing just 4 reflections, here we can easily hear 50 to 60 reflections, giving us an extremely strong reverberation. So let's simulate what that would sound like. So here's what reverberation sounds like with about 50 to 60 reflections. Ready for this? Here goes. Yo! It's still there. It's still there. All right. So if the time gap between successive reflections is a lot, we'll call them as echoes. And if it's very small, we'll call them as reverberation. But one question we might have is how much time gap is needed for echoes and for reverberation? Well, research shows that if the time gap is more than 0.1 second, then we can hear the sounds distinctly, and then we'll call them echoes. And so if the time gap is less than 0.1 seconds, then our brains can't tell when one sound ends and the next one begins. And that's when we'll call them reverberation. And of course, if the time is close to 0.1 second, it could be a gray area. It could be sort of an echo and reverberation together. And lastly, how do we reduce reverberation? Whether you want to deliver a speech in a large hall or I want to record my videos over here, reverberations can make it difficult to understand what people are saying. So in such cases, we need to reduce it as much as possible. And that can be done by introducing sound absorbing materials in your room. Because if sound gets absorbed, then there will be less reflection, less reverberation. This can be done by having open windows or carpets, cushions, and even people. And for the same reason, in my room, I have this sound absorbing foam, this beanbag, this carpet, and a very questionable blue curtain. All these things absorb sounds and reduce reverberation. So what did we learn in this video? We saw that if the time gap between the original sound and the reflected sound is big enough, at least about 0.1 second, then we hear echoes. And if it's less than 0.1 seconds, then our brains cannot identify the individual sounds, and we call it reverberation. And excessive reverberation can be annoying, and so we can reduce it by introducing sound absorbing things.
Wow, what an interesting video. I learned what an echo is and that sound vibrates. Hope you enjoyed today's lesson. See you in our next class.